Imagine a custom-engineered steel cylinder, right? Like roughly the size of a professional football pitch.
Yeah, massive.
And it operates under such immense continuous pressure that a single microscopic fracture could just cause a catastrophic failure.
Right.
Now, try to imagine rebuilding that exact cylinder from scratch after it's been punctured by a drone strike, only to realize that your entire continent, like the whole continent, no longer possesses the thermal energy required to even forge the replacement steel.
It's a terrifying scenario.
Welcome to the terrifying physics of modern warfare. And if you were listening to this right now, I know you are the type of person who wants to cut through the noise of daily headlines.
Yeah.
You aren't looking for political spin.
Exactly.
You want to understand the actual mechanics of how the world operates when the cameras are turned off. And that is our mission for this deep dive today.
It's a big one.
It is. We are going to unpack a highly detailed, deeply technical, and frankly, very controversial assessment of global supply chains, military logistics, and just the raw physical limitations of power.
And because of the nature of this material, we really need to establish some very clear ground rules right at the top.
Definitely.
So today's source material is centered around an extensive interview with Stanislav Krapivnik. And just for context, he is a former United States Army officer. His post-military career involved significant work as a global supply chain manager for massive energy and infrastructure projects across Eurasia.
Which gives him a really unique perspective.
It does. But in the source material we're examining today, he makes some deeply polarizing, politically charged claims regarding Western leadership, the war in Ukraine, the Baltic states, and the Middle East.
Which means we really need to draw a very firm line here.
Exactly. Let me explicitly state this to you, the listener. We are not endorsing these viewpoints.
Right.
We are not taking sides, and we are not here to validate the politics or the historical interpretations presented in this interview. Our goal today is strictly analytical.
Just the facts of his argument.
Yeah, we are examining his technical arguments and his logistical assessments to understand exactly how he views these global flashpoints. We're dissecting the mechanics of his argument, understanding the structural vulnerabilities he points to, but we are absolutely not advocating for his worldview.
I'm really glad we laid that out. Because the roadmap we have ahead of us today it's massive. And it requires that clinical objective lens.
It really does.
So we're going to start geographically, examining his claims about snapping tripwires and shifting red lines in the Baltic states. From there, we'll follow his logic into the Middle East, exploring the brutal logistics of repairing highly specialized energy infrastructure.
The 78-meter vessels, yeah.
Right. Then we'll analyze his prediction of a three-wave global crisis if that infrastructure falls. Then we pivot to the military realities of what he terms Fortress Iran.
Which is fascinating.
And finally, we will break down his highly critical assessment of the information bubble surrounding U.S. leadership.
It is a sobering journey through the physical realities of global power, stripping away the rhetoric to look entirely at constraints. Steel, diesel, water, and geography.
Okay, let's unpack this, starting geographically, with where Krapivnik sees the informal rules of proxy warfare completely breaking down. He zeroes in heavily on the Baltic states.
He does, yeah.
And specifically, a recent drone attack that he views as a massive, unrecognized escalation.
Right. So he focuses on a coordinated strike targeting a key Russian port on the Baltic Sea, as well as the Pskov airbase. And his entire argument here hinges on the raw geography and the physical limitations of the technology involved.
Okay.
He points out that this attack involved a swarm of roughly 30 to 40 drones. The targets, specifically Pskov, are located about 47 kilometers away from the Estonian border, but they are well over 1,000 kilometers away from the Ukrainian border.
Now, I want to push back on his immediate conclusion here, because my first thought, and probably the thought of anyone looking at this critically, is localized sabotage.
Right, someone in a van.
Exactly. Is he completely ruling out the possibility of a localized launch by operatives or partisans already inside Russia?
He largely dismisses it, yeah, and he bases that on the logistical footprint of the hardware. We aren't talking about tiny commercial quadcopters that you can just launch from the back of a pickup truck.
Not the ones you buy at the electronics store.
Exactly. To carry a payload capable of heavily damaging military transport aircraft or port infrastructure, you are typically looking at fixed-wing, long-range drones. These have significant wingspans, they require substantial fuel or heavy battery payloads,
Right.
and critically, they often require a runway or a heavy pneumatic catapult to launch. So smuggling 40 of these systems deep into the Russian interior, assembling them, fueling them, and launching a coordinated swarm simultaneously without detection by internal security is, well, in his logistical assessment, it's highly improbable.
Okay, so if we accept his premise that a deep interior launch is basically off the table, and we look at the 1,000-kilometer distance from Ukraine, he looks at the flight paths and deduces what?
Well, he notes that to reach Plexkov from Ukraine, a swarm of 40 large drones would have to navigate an incredibly complex path. They'd have to completely evade Belarusian airspace, which is heavily monitored by integrated air defense systems.
Which is tough to do with a swarm.
Yeah, almost impossible. Furthermore, he points out that 2 drones actually hit targets within the Baltics themselves during this time frame.
Wait, really?
Yeah, one struck a power plant chimney in Estonia, another hit an object in Latvia. So, taking all this geographic and telemetry data together, Krapivnik makes a firm deduction. He says it is practically impossible for this swarm to have originated from Ukraine.
So where does he think they came from?
He argues they either originated from or were allowed to pass directly through NATO territory, specifically Estonia and Latvia.
Which brings him to a very blunt binary conclusion regarding the Baltic governments. He essentially says, Option A is that the integrated air defense radar systems of Poland and the Baltic states are so utterly incompetent that 40 military-grade drones can fly through their sovereign airspace completely undetected.
And let's clarify why he thinks option A is just absurd.
Okay.
Modern military radar systems, especially those guarding NATO's eastern flank, are designed to detect targets with a specific radar cross-section. While drones are smaller than fighter jets, a swarm of 40 fixed-wing drones flying in a coordinated formation creates a highly visible radar signature.
Right, it's not stealth technology.
Not at all. They also emit thermal signatures and radio frequency signals for navigation and control. The idea that multiple sovereign defense networks simply didn't notice them is, to him, laughable.
Which leaves his option B, the reality he believes is true, that they are complicit. He argues that allowing or facilitating this flight path makes these nations direct participants in military engagement with Russia.
Yes.
But if he genuinely believes this is happening, why does he focus so heavily on Estonia specifically? I mean, it's a tiny nation. To understand his perspective, we really have to understand how he frames the geopolitical friction there.
Yeah. He builds his justification using a mix of demographic friction and deeply controversial historical claims. He paints a picture of intense, systemic hostility.
Right.
First, he points to demographics, claiming that roughly 50% of Estonia's population is Russian. He specifically zeroes in on the city of Narva, which sits right on the border, stating it is 95% Russian and has been since the 1200s.
And he argues that these ethnic Russians are subjected to a system where they are treated as third-class non-citizens.
A disgrace, yeah.
He brings up the concept of gray passports, essentially arguing they're disenfranchised by what he calls a deeply anti-Russian or Russophobic government in Tallinn.
Exactly. And then he layers on a very specific historical interpretation to sort of delegitimize the state itself. He claims that the Baltic states are artificial entities that didn't exist as sovereign nation states until 1917.
Right, emerging only after the collapse of the Russian Empire.
Yeah. And he goes even further back, arguing that historically the land was legally purchased by Peter the Great from Sweden following the Great Northern War in the early 18th century.
He essentially views it as an 18th century real estate transaction.
Right.
He says, Russia bought the real estate, the receipt just didn't mention the people.
Right.
Which, frankly, is an incredibly provocative and dismissive way to view sovereign nations recognized by international law today.
Absolutely.
But understanding that he views it this way is crucial, because he uses this history to frame Estonia not as an independent victim of proximity, but as an occupying entity acting aggressively on what he considers Russian land.
And that framing is exactly why he perceives the situation not as defensive posturing by NATO, but as active border terrorism. And he doesn't just focus on drones in the sky. He talks about literal physical friction at the border crossings to illustrate how volatile the situation has become.
Right, the smuggling anecdote. This is a striking detail.
Yeah.
He describes a transport truck coming through Poland carrying a shipment of electric boot insoles. These are the thick, heated insoles you would use to keep feet warm in sub-zero environments.
Yep.
Likely destined for military use or for refugees in cold climates.
Right.
But upon inspection, inside every single one of these insoles, someone had intricately hidden 1.5 grams of explosives.
Now, mechanically speaking, 1.5 grams of explosives, likely something highly stable like RDX or PTN, is not enough to bring down a building. It's roughly the amount you might find in a very large firecracker.
So it's not a massive bomb.
No, but the payload isn't the point. The point is the intent and the scale.
Yeah.
When you have thousands of these packed into a transport truck and you multiply that constant low-level friction, that deliberate smuggling of lethal material across a border week after week, month after month, he uses this to describe a psychological reality.
He's describing a spring being compressed.
Yes.
In Western strategic circles, we constantly hear about salami tactics, the idea that you can escalate a conflict in tiny incremental slices, a drone strike here, a weapon shipment there, a truck of explosives here.
Right.
The theoretical belief is that if you keep the slices small enough, the adversary's threshold for a massive retaliatory escalation is never quite reached.
Well, what's fascinating here is that Krapivnik completely and utterly rejects the premise of salami tactics when applied to Russia. He argues that Western strategists are fundamentally misinterpreting Moscow's unwillingness to instantly expand the war as a sign of weakness or paralysis.
He uses an old Russian proverb to illustrate this cultural and strategic mindset.
Right.
Something about a horse.
Yeah, he mentions a couple of variations. One is, Ivan is slow to get on his feet, but when he gets on his feet, blood flows.
Wow.
Another version is that Russians are very slow to saddle the horse, taking their time to prepare, but once they are finally in the saddle, they gallop incredibly fast.
I see.
So Krapivnik is arguing that NATO's incremental escalations, the drones, the border smuggling, they are not successfully deterring Russia or paralyzing their decision-making. They are simply exhausting a finite reservoir of patience.
And when that patience runs out, assuming his assessment of their strategic culture is correct, the response won't be a proportional slice of salami. He explicitly states that major Russian political figures on mainstream talk shows are openly calling to paint the walls with Estonia, to set a definitive example and reset the deterrence matrix. He believes the tripwire hasn't just been stressed, it has been thoroughly snapped.
This erosion of informal proxy rules, this idea that red lines are being ignored because one side thinks the other is bluffing, is a dangerous dynamic anywhere. But if we track the mechanical causality here, the implications become staggering when you take that exact same behavioral model, the unrestrained crossing of red lines, and apply it to a different part of the world.
A region where the physical infrastructure simply cannot survive a lapse in deterrence.
Exactly.
Which pulls us directly out of the Baltics and into the Middle East. And before we dive into the nightmare scenario he outlines here, we have to establish why Stanislav Krapivnik's voice holds specific weight on this particular topic.
Right, his background.
Because it's easy for military analysts to look at a map and say, if they bomb this refinery, oil prices go up. But Krapivnik isn't just looking at the macroeconomics. He was the guy holding the blueprints.
Exactly. This is where his expertise is deepest and most relevant. After his military service, he became the regional director of supply chain management for Halliburton in Eurasia.
Cool.
He was directly responsible for the logistics of everything from the subterranean wellheads to the sprawling above-ground processing infrastructure. He later worked as a supply chain director on massive, multi-billion-dollar construction projects for TechNet.
We're talking about overseeing the expansion of the Moscow refinery. We are talking about managing the supply chain for a 15 billion euro Gazprom LNG plant in Amur.
Massive projects.
And for our listeners, LNG, liquefied natural gas, is an incredibly complex engineering feat. You are taking natural gas, which takes up a massive amount of volume, and cooling it to roughly minus 260 degrees Fahrenheit so that it shrinks to 1/1600th of its original size.
Just to put it on a boat.
Right, allowing it to be shipped on specialized tankers. The infrastructure required to compress, cool, and store that gas safely is mind-bogglingly intricate.
It is the absolute pinnacle of industrial engineering. And Krapivnik uses that intimate, hands-on knowledge to fundamentally dismantle a very common assumption in the West.
Which is?
The idea that if a refinery in the Middle East gets hit by a missile, it's basically a pothole in the global economy. You fill it in, send a repair crew out, and a few weeks later, you're back online.
Right.
Krapivnik provides a masterclass on the anatomy of a refinery repair, focusing heavily on what are known as process vessels.
Okay, process vessels. When I hear that, I picture, like, a large industrial vat or a holding tank.
Yeah.
But he is describing something entirely different.
Vastly different. In the major projects he managed, they dealt with around 120 of these specific process vessels. Some were relatively standard, maybe 1 to 3 meters in length. But the critical components, the heart of the refining process, were custom-designed behemoths. He talks about vessels reaching up to 78 meters long. 78 meters. That is the size of a professional football pitch. Just one single piece of pressurized equipment.
Yes, and he meticulously walks through the nightmare of just acquiring and installing one of these, assuming peacetime conditions.
Okay, walk me through it.
First, you have to understand they are not mass-produced. There is no warehouse in the world that just stocks 78-meter process vessels. You can't order one from an industrial catalog.
Obviously not.
They are engineered to order, designed specifically for the exact chemical composition, temperature, and pressure requirements of that specific refinery. They require various nozzles, flanges, and internal sections to be welded and assembled manually, often by highly specialized metallurgists. It is all done by hand to tolerances measured in millimeters.
And the testing process he describes, you don't just build it, load it on a truck, and plug it in. He talks extensively about hydrotesting. Yeah, hydrotesting is mandatory and incredibly arduous. You have to take this massive 78-meter structure, seal it, and fill the entire internal volume with water. Then you use massive industrial pumps to pressurize that water far beyond the vessel's normal operating limits.
Why water?
Because water doesn't compress easily. So if there is a single microscopic flaw in the forging or a weak point in a weld, the pressure will expose it safely, meaning it will just leak water rather than exploding with highly combustible gas later. Once it passes the pressure test, you have to drain it and then completely perfectly dry the interior to prevent corrosion before the actual gas or oil is introduced.
And that's just at the manufacturing facility. Then you have to physically move a football pitch-sized steel cylinder across the earth.
The logistics of transport are staggering. For a vessel of that size, you aren't just putting it on an 18-wheeler. You need custom-built, multi-axle modular transporters. Krapivnik mentions that during one of his projects, the convoy was so massive that they literally had to use giant cranes to lift entire administrative buildings out of the way just to allow the truck to turn a corner.
That's insane.
It is. Once it finally arrives at the refinery site, it has to be rigorously hydrotested all over again to ensure the journey didn't create new microfractures. Dried out again, and then carefully lifted into its final vertical or horizontal position. From the moment the purchase order is signed to the day it is installed, for one vessel, it is a 7 to 8 month operation. And again, that is during peacetime, with all global supply chains functioning perfectly.
So let's apply his logistical reality to a combat scenario. Let's say a relatively cheap kamikaze drone or a cruise missile manages to bypass air defenses and strikes a major Qatari gas refinery or an Iranian oil facility. It hits one of these 78-meter process vessels and punches a hole through the side.
Right.
The instinct of a politician or a layman watching on the news is, well, patch the hole. Fly a team of expert welders out there, put a steel plate over it, and turn the machines back on. But Krapivnik says that is physically impossible.
It is absolutely impossible because of the physics of pressure vessels. When a massive steel cylinder operates under high internal pressure, the structural integrity relies on the continuous, unbroken distribution of what engineers call hoop stress.
Hoop stress.
Yeah, the entire circumference of the vessel shares the load equally. If a missile punches a hole in it, the heat and concussive force fundamentally alter the metallurgy of the surrounding steel. It introduces microfractures radiating out from the impact zone.
So you can't just weld it.
Exactly. If you just weld a plate over the hole, that weld and the weakened steel around it becomes a massive stress concentration point. The moment you introduce high-pressure gas back into the system, the patch will violently blow out. It will not hold the pressure.
Meaning you can't repair it.
You cannot repair it. If a missile puts a hole in a process vessel, that multi-million-dollar, custom-engineered marvel of modern science instantly becomes useless scrap metal. You have to shut down the entire line, spend weeks safely cutting the massive damaged vessel out of the intricate piping network, clear the debris, and order a completely new one from scratch.
So it's not like swapping a flat tire on a car. It's like trying to repair a damaged spacecraft while it's in orbit. You can't just slap duct tape on it. The physics of the environment won't allow it.
Exactly.
But the nightmare gets worse, because Krapivnik points out a massive structural bottleneck at the very beginning of the supply chain, the raw materials. To build the replacement vessel, You need specialized steel.
Yes, you need custom-forged steel ingots. You can't use standard construction steel. You require specific alloys capable of withstanding extreme temperatures and corrosive chemicals. According to Krapivnik's timeline, simply casting and forging the raw ingot at a specialized mill takes about a month and a half before the machining even begins. But here is the truly critical systemic vulnerability he points out regarding European manufacturing capacity. He argues that Europe right now cannot produce this specialized steel in meaningful volumes.
Wait, why not? Europe has historically been an absolute powerhouse of heavy industry. They have massive steel mills in Germany and France.
They have the physical mills, but they no longer possess the cheap thermal energy required to operate them efficiently. Steel production, particularly processes involving direct reduced iron or running massive electric arc furnaces, requires colossal amounts of energy.
Ah, I see where this is going.
For decades, Europe's heavy manufacturing base relied on a continuous, incredibly cheap flow of natural gas from Russia. When Europe cut itself off from that supply due to the conflict in Ukraine, energy prices spiked. Krapivnik argues that this didn't just cause inflation, it fundamentally crippled the economic viability of European heavy industry. Producing specialized forged steel ingots in Europe has become cost-prohibitive or physically impossible due to energy rationing.
So if Europe is out of the picture, who is left? Who actually has the energy surplus and the manufacturing base to forge the steel needed to fix these refineries?
According to Krapivnik, there are only 3 nations left that can produce this specialized equipment in the volume and quality required: Russia, China, and the United States. He mentions that perhaps tiny amounts could be sourced from India or Brazil, but nowhere near the scale needed for a massive rapid reconstruction.
If we follow his logic to its conclusion, the irony is devastating. The very countries that the West is currently locked in severe proxy conflicts or economic wars with Russia and China are the ones holding a near monopoly on the raw manufacturing capacity needed to fix the vital infrastructure the West relies on.
It's a massive structural vulnerability.
But let's say the missile doesn't hit the above-ground refinery. Let's say it hits the extraction point itself, the wellhead.
If the wellhead is targeted, a disaster turns into a multi-year catastrophe. The wellhead is the physical structure at the surface, often referred to in the industry as the Christmas tree, because of its complex arrangement of valves, spools, and gauges that control the flow of gas or oil from the subterranean reservoir.
Okay.
If just the top valves are damaged, sometimes they can be replaced. But if a kinetic strike damages the main pipe itself deep below the surface, or if the explosion causes massive debris shards of steel, concrete to fall down into the wellbore, the situation changes entirely.
You can't just flush it out like a clogged drain. The pressure's coming up.
Exactly, and you can't just reach down and grab the debris. The wellbore might be thousands of feet deep. Krapivnik describes the agonizing process of having to use massive, specialized electromagnets, lowering them thousands of feet into a narrow, dark pipe, blindly trying to fish broken pieces of jagged metal out of the hole.
And if the fishing expedition fails,
Yeah.
if the well is structurally compromised deep underground,
Then the well is dead. The entire extraction point is lost. You have to execute a complex procedure to permanently plug the damaged well with cement to prevent a massive environmental blowout. Then you have to clear the site, bring in a completely new massive rotary drilling rig, and drill an entirely new wellbore from scratch through thousands of feet of rock to reach the reservoir again. This process takes additional months and very frequently years.
So when Krapivnik synthesizes all this, his experience with 78-meter vessels, the loss of European steel forging capacity, the impossibility of patching high-pressure pipes, and the reality of wellhead damage, what is his bottom line assessment? When he looks at the Middle East, what is his timeline for recovery if a major facility goes up in flames?
He estimates an absolute minimum of a 1.5 to 2 year delay before a heavily damaged facility, such as a major Qatari gas processing hub, could be brought back to functional capacity. And he stresses that this is not a problem you can solve by simply throwing billions of dollars at it. The physical manufacturing capacity, the cheap steel, the custom engineering, the heavy lift transport simply doesn't exist on a timeline that the global economy can survive.
Which provides the perfect, albeit terrifying, logical transition to the next section of his analysis. Because if the world cannot physically fix the infrastructure for 2 years, the immediate question becomes, what happens to the rest of the world during those 2 years?
Right.
Krapivnik outlines a cascading failure of global systems. He calls it the three waves of crisis.
Yes. Having established the mechanical reasons why the infrastructure will remain broken, he maps out the unavoidable global fallout. The first wave, hitting almost immediately upon the destruction of the facilities, is the energy shock.
Right. And he puts hard numbers on this, specifically regarding natural gas. He estimates a sudden, permanent 20 to 25% reduction in the total natural gas available in the global market.
Huge drop.
Now, you hear politicians in the West say, well, if Middle East gas goes offline, we have vast reserves in the U.S., we'll just drill more here, drill baby drill. But Krapivnik absolutely shreds that political talking point using the reality of geological timelines.
He does because, again, he understands the supply chain of extraction. You cannot just walk out into a field, flip a switch, and instantly produce more natural gas to replace a 25% global deficit.
It doesn't work like that.
Not at all. To bring a completely new field online, what the industry refers to as drilling a wildcat well in an unproven area takes a minimum of 3 to 5 years. You have to conduct extensive seismic surveys, secure land rights, environmental permits, mobilize massive drilling rigs, actually drill and case the wells, and then construct the intricate pipeline infrastructure required to transport the gas to an export terminal.
And his point is that the crisis isn't arriving in 3 to 5 years. The crisis is arriving next week. You cannot plug a massive, immediate gaping hole in the global energy supply with wells that won't produce a single usable molecule of energy for half a decade.
Exactly. So wave one hits. Global energy markets panic, supply vanishes, and prices for whatever fuel is left skyrocket to unprecedented levels. But it's the second wave that truly demonstrates the interconnected fragility of the modern world. Almost immediately following the energy shock, wave two hits, and Krapivnik identifies wave two as starvation.
Wow.
He states that by midsummer, following an infrastructure strike, global food production will begin to collapse.
Here's where it gets really interesting and frankly deeply unsettling. He illustrates the hidden absolute dependency between the energy sector and the agricultural sector. We tend to think of energy primarily as electricity to keep the lights on, or gasoline for our morning commute. But Krapivnik points out that energy is the fundamental, non-negotiable building block of the global agricultural supply chain.
We have to move away from the idyllic image of a farmer plowing a small field. Modern global agriculture relies on mega-farms operations spanning thousands upon thousands of acres. These massive yields simply cannot be harvested manually. You can't plow 5,000 acres with a team of oxen.
Right. You require fleets of heavy, specialized machinery. Massive tractors, combined harvesters, irrigation pumps.
Yes.
And those machines do not run on electricity. They run on colossal amounts of cheap diesel. It's essentially the same logistical problem the military faces. An M1 Abrams tank consumes hundreds of gallons of jet fuel a day just to move. A fleet of modern combined harvesters running 14-hour days during harvest season consumes diesel at a staggering rate.
Precisely. And if global refining capacity is severely crippled, diesel supplies vanish or become prohibitively expensive. Farmers physically will not be able to afford the fuel to put seeds in the ground or harvest the crops that do grow.
That's terrifying.
Krapivnik notes that Russia, understanding this vulnerability intimately, currently maintains a strict ban on exporting their own diesel until at least mid-May, specifically to guarantee supply for their domestic planting season.
Interesting.
So immediately, global caloric production drops because the mechanical muscle of farming is paralyzed. But the lack of diesel is actually only half the problem. The true catastrophic failure point is the fertilizer crisis.
Right. Because to feed 8 billion people, modern farming relies absolutely on chemical fertilizers to achieve high crop yields. The natural nutrients in the soil alone cannot support the global population.
And where exactly do those fertilizers come from?
They come directly from the fossil fuel industry, specifically natural gas.
Mm-hmm.
According to Krapivnik's figures, a global supply of chemical fertilizer is incredibly concentrated. He states that Russia produces roughly 40% of the world's supply. Qatar produces another 30%.
Wait, 70% of the total global supply of chemical fertilizer comes from just 2 regions. Yes. And to understand why, we have to look at the chemistry specifically, the Haber-Bosch process. This is perhaps one of the most important industrial chemical processes ever invented, literally responsible for sustaining billions of lives.
Okay, break that down for me.
The Haber-Bosch process takes nitrogen directly from the air and binds it with hydrogen to create ammonia, which is the foundational ingredient for nitrogen-based fertilizers. But to do this, you need 2 things. First, you need a source of hydrogen, which is primarily stripped from methane natural gas.
Ah, okay.
Second, the chemical reaction requires immense heat, around 500 degrees Celsius, and extreme pressure, often over 200 times normal atmospheric pressure.
So natural gas isn't just powering the factory. Natural gas is the actual physical feedstock, the raw ingredient, being chemically transformed into the fertilizer.
Exactly. It is highly energy intensive and highly dependent on cheap methane. Because Europe's natural gas has become incredibly expensive after cutting ties with Russian pipelines, Krapivnik points out that Europe produces exactly zero chemical fertilizer now. The energy inputs make it economically impossible to run the Haber-Bosch process at a profit.
He even brought up a staggering statistic, noting that the United States, which is an agricultural superpower with vast domestic resources, still had to import over $500 million worth of Russian fertilizer last year just to keep American farms running at capacity.
If we connect this to the bigger picture, Krapivnik is stripping away the illusion of agricultural independence. He is showing us that modern society is a highly fragile construct, entirely reliant on incredibly cheap, concentrated energy inputs.
Right.
The destruction of Qatar's gas infrastructure doesn't just mean a colder winter in Germany because there's less gas for the stove. It means the immediate loss of the world's chemical ability to induce the growth of enough food.
Which leads directly into the bleakest part of his timeline, Wave 3, winter. By the time the first winter arrives following an attack, the strategic fuel reserves are completely empty, and the reduced agricultural yields mean global food reserves are gone. He shares a very specific, heartbreaking anecdote from a colleague, a politics professor in northern Italy.
Yes, the professor noted that right now, even before any massive Middle East escalation or infrastructure strike, lower middle-class Italian families are financially exhausted by the energy crisis. They are running out of money for basic groceries by week 4 of the month.
So, assuming his timeline is accurate, what happens when Wave 1 and Wave 2 fully materialize? When the price of heating fuel triples and the cost of the vastly reduced global food supply skyrockets? You don't just see a high inflation report. You see class-based starvation within developed Western nations. You see lower middle-class populations literally unable to afford the calories to survive or the heat to keep from freezing.
He describes it as a tidal wave. We are accustomed to treating energy as a tradable commodity on a stock ticker, but Krapivnik is violently resetting that definition. He is stating that energy is food. Energy is survival. The system has zero elasticity.
And that extreme rigidity, that inability to absorb a shock, extends beyond the global economic system. It actually defines the very structural reality of the nations that host this vital infrastructure. Let's pivot and look at the Middle East itself through Krapivnik's lens. If the global consequence of an attack is starvation, what happens to the specific Gulf states sitting directly on top of the blast zone?
Krapivnik takes a very clinical, almost cynical approach to analyzing Gulf states like Qatar and Bahrain. He argues that Western analysts make a fundamental error when they evaluate these countries as traditional nation-states with deeply rooted, patriotic citizen populations willing to endure hardship for the homeland.
Right, how does he describe them?
Instead, he describes them functionally as corporations run by a single family.
He backs that up with staggering demographic data. He points out that roughly 85 to 90% of Qatar's entire population, for instance, is comprised of foreign workers, expatriates. Everyone from the laborers building the stadiums to the highly specialized engineers running the Haber-Bosch fertilizer plants.
Yeah.
They are there executing a contract for a paycheck. They are not there out of a deep sense of national loyalty or shared historical destiny.
It's essentially a massive company town. If the factory burns down and the paychecks stop, the workers have zero incentive to stay and fight the fire. They will simply leave. The country, as a functioning entity, literally evaporates.
And Krapivnik points out that an adversary wouldn't even need to launch a massive World War II-style ground invasion to cause that evaporation.
Right.
They wouldn't need to fight the Qatari military tank for tank. They simply need to hit the state's most glaring vulnerability, the desalination infrastructure.
This is the ultimate Achilles heel. These are desert nations. They do not have vast freshwater aquifers or major river systems. They rely almost 100% on massive, incredibly complex desalination plants to convert seawater from the Persian Gulf into drinkable water.
And just like fertilizer production, desalination is an energy glutton.
Absolutely. Most modern plants use reverse osmosis, which involves using massive industrial pumps to force seawater through microscopic, semi-permeable membranes at pressures often exceeding 1,000 pounds per square inch. It requires a continuous, massive supply of electricity.
So if the power goes out,
If an adversary targets the power grids running those plants or uses precision strikes on the high-pressure pumps within the plants themselves, the water stops flowing. In a desert environment, human life in those dense modern cities becomes physically impossible within a matter of days.
You don't have to defeat their army. You just have to turn off the water taps.
Krapivnik emphasizes the concept of human capital flight. The highly skilled engineers, the Western technocrats, the foreign medical staff who keep these energy empires functioning, they are not going to stick around in an active war zone where they cannot guarantee a glass of clean drinking water for their children.
No, of course not.
They will take their families and leave on the first available commercial flight out of Doha or Manama. And once that intellectual capital leaves, they will not return until the infrastructure is perfectly secure and functional, which, as we already established with the 78-meter process vessels, takes years.
So Krapivnik poses this ultimate existential question for the ruling families of these Gulf states, the emirs and the sheiks. Let's assume the nightmare scenario happens. The facilities are hit, the water is compromised, the expatriates flee. Do the ruling families dig in?
Right.
Do they commit to spending 3 to 5 years investing trillions of dollars of their own accumulated sovereign wealth to rebuild a completely destroyed infrastructure from the sand up, all while receiving zero export revenue because the gas isn't flowing?
Or do they look at the mathematics of this situation, realize the corporation is functionally bankrupt, and choose to simply cut bait and run?
Right. Do they take their trillions of dollars that are already safely diversified and parked in real estate in London, or sitting in Swiss bank accounts, and just choose to live as unimaginably wealthy expatriates themselves, letting the desert slowly reclaim the glass skyscrapers?
It is a profound psychological and strategic assessment. Krapivnik is outlining an asymmetric doctrine. The strategy of an adversary, say Iran or its allied proxy groups, wouldn't require marching infantry battalions into Doha to occupy the territory. They simply need to threaten the basic physical survivability of the state.
By targeting water and energy.
Exactly. By doing that, they force an immediate demographic collapse. They make the corporation wildly unprofitable to fix, effectively neutralizing the state without a traditional war of conquest.
It is a terrifyingly efficient, brutal way to look at modern warfare, which leads perfectly into how Krapivnik views the main regional adversary that possesses the capability to execute this kind of asymmetric warfare. If the Gulf states are fragile glass houses, completely reliant on uninterrupted complex systems, how does he describe Iran?
He uses one very specific defining phrase throughout his analysis: Fortress Iran. He views a potential U.S. ground intervention or prolonged military campaign against Iran not just as a poor strategic choice, but as a logistical and military impossibility given current force structures.
He paints a picture of intense asymmetry, starting with the raw geography. I think many people hear war in the Middle East, and their minds immediately default to the flat, open deserts of Iraq, where U.S. armored columns could maneuver relatively freely. But Iran is a completely different topological reality.
Vastly different. Krapivnik emphasizes that Iran is roughly 4 times the physical size of Iraq. It is bordered by seas on 2 sides, but the interior and the borders are dominated by massive, rugged, highly impenetrable mountain ranges like the Zagros. Furthermore, it is populated by nearly 90 million people. Based on the sheer scale of the terrain and the population density, Krapivnik calls it the biggest fortress in the world.
Now, a skeptic might say, okay, the geography is tough, but the United States possesses the most technologically advanced, powerful military in human history. Surely they have the capability to crack a fortress, even a massive one.
And this is where Krapivnik forcefully breaks down the reality of U.S. force structure versus the mythology of it. He argues that fundamentally, the United States is structured as a supreme sea and air power. It is designed to project force globally via aircraft carriers and bomber fleets.
Okay.
It is not, however, currently structured as a massive land power capable of conquering and occupying a hostile, mountainous country of 90 million people. He looks closely at the numbers to prove this. The U.S. Army and Marines combined have an active duty force of roughly 550,000 troops. But he points out a massive, often misunderstood caveat regarding that number.
The tooth-to-tail ratio.
Exactly. The tooth being the combat forces, the tail being the logistics. Out of that 500,000 personnel, he estimates only about 120,000 are actual frontline combat troops. The infantry, the armor crews, the special operators. The vast majority of the modern U.S. military comprises what he bluntly, in military slang, refers to as ash and trash.
Ash and trash. That's a harsh term for people serving in uniform. Let's break down what that actually means in a modern context.
It's not meant to demean their service. It's a cold logistical categorization. It refers to the massive logistical tail required to keep a modern, high-tech military functioning. It's the Teamsters driving the fuel trucks, the specialized aviation mechanics, the finance battalions, the medical units, the intelligence analysts, the cyber warfare technicians. In previous centuries, say during Napoleon's campaigns, armies traveled with massive civilian camp followers who handled cooking, repair, and supply. Today, all of those essential functions are performed by uniformed military personnel. They are absolutely vital for keeping the army running, but they are not trained combat infantrymen designed to clear a fortified mountain bunker.
To put that in perspective, an armored brigade combat team uses an astronomical amount of resources. A single M1 Abrams tank requires over 300 gallons of fuel a day, just for basic operations. When you have dozens of those, plus Bradley fighting vehicles, you require a constant vulnerable convoy of heavy fuel trucks, mechanics to fix the trucks, and security details to guard the mechanics, just to move the combat element a few miles.
Exactly.
So his point is, if you attempt to invade Fortress Iran, you aren't sending 500,000 riflemen over the border. You are sending maybe 120,000 actual combat troops against a heavily entrenched, mobilized population of 90 million fighting in their own mountains.
And Krapivnik's critique doesn't stop at the numerical ratio. He takes a very critical look at the physical readiness of the personnel pool the U.S. currently has to draw from. He highlights a severe systemic recruitment crisis, claiming that the obesity rate within the U.S. military ranks currently sits around 22 to 23%.
He even brings up a specific example, referencing former President Trump deploying the Texas National Guard to the southern border, claiming that if you look at the footage, many of those infantrymen were visibly unfit for the rigors of high-intensity combat.
He's making a brutal point about stamina, survivability, and the realities of infantry combat. In mountain warfare, against a determined, dug-in defender physical fitness, the ability to carry 80 pounds of gear up a steep incline under fire is literally the difference between life and death.
Yeah, you can't fake that.
No. Furthermore, if the U.S. recognized this shortfall and needed to institute a national draft to get more bodies into the infantry, Krapivnik argues the administrative infrastructure of the selective service system is so dilapidated that it would take 4 to 5 months just to organize the paperwork and mail the notices, let alone begin the months-long process of training civilians for combat.
Okay, so based on his logistical analysis, a massive ground invasion is entirely off the table. It's a non-starter.
Right.
But the U.S. doesn't necessarily need to invade. What about the Navy? What about securing the critical choke points, specifically the Strait of Hormuz?
Right.
The U.S. has these massive nuclear-powered carrier strike groups and incredibly advanced Aegis destroyers. Surely they can maintain freedom of navigation.
This raises an incredibly important question about how cheap asymmetric technology has fundamentally altered the balance of naval dominance. Krapivnik looks closely at the geography of the Strait of Hormuz. At its absolute narrowest point, the strait is only 36 kilometers wide. But the crucial detail, the navigable reality for massive supertankers and deep draft warships, is the dredged canal. That deepwater lane is only 2,700 meters wide.
That is basically a narrow, predictable hallway in the middle of the ocean.
And surrounding that hallway are numerous small islands and complex coastlines perfectly suited for launching the ultimate modern asymmetrical weapon, FPV drone swarms.
FPV, first-person view drones.
Yeah.
We're talking about the relatively cheap, off-the-shelf commercial drones you can buy online, where the pilot wears VR goggles that give them a literal missile's eye view, removing the need for heavy, complex targeting computers.
Yes, but in this scenario, modified to carry lethal payloads, 20-kilogram battery packs designed to cause massive kinetic damage or specialized RPG rounds. And an RPG, a rocket-propelled grenade, uses a shaped charge. It uses explosives to turn a copper cone into a hypersonic jet of molten metal, specifically designed to punch through heavy ship armor. Krapivnik details a scenario where an adversary doesn't need a billion-dollar air force to close the strait. They just need a few hundred teenagers with VR goggles sitting under the camouflage of trees on a small island like Abu Musa, waiting for a ship to pass through that 2,700-meter hallway.
But again, I have to ask about the defenses. An Arleigh Burke-class destroyer uses the Aegis combat system. It has the SPY-1 radar, which is basically a supercomputer capable of tracking hundreds of incoming missiles simultaneously and guiding interceptors to destroy them. It is designed to be an impenetrable shield.
It is a brilliant system, but Krapivnik points out it has a physical limit regarding processing and firing channels. Think of the Aegis system like a chess grandmaster playing a simultaneous exhibition against 50 opponents. The Grainmaster is brilliant and can track all the complex moves. But if someone suddenly dumps a bucket of 10,000 live fire ants onto the chessboards, the Grandmaster is completely defenseless. The system is overwhelmed by sheer, chaotic volume.
So it's just a numbers game?
Completely. Krapivnik argues that no Aegis destroyer, no matter how advanced its radar or how many missiles it holds in its vertical launch tubes, can survive a coordinated swarm of 100 explosive drones launched simultaneously from just a few miles away. The ship simply doesn't have enough interceptors or the physical time to shoot them all down before the swarm impacts the hull and the radar arrays.
So he is suggesting a scenario where a billion-dollar warship, representing the pinnacle of U.S. engineering, with a highly trained crew of 350 sailors, is effectively crippled or sunk by $50,000 worth of plastic, batteries, and shaped charges.
And he cites real-world examples to validate this vulnerability. He points to an alleged attack by MI6 on a Shadow Fleet ship off the coast of an African island using FPV drones equipped with RPGs as a proof of concept. The asymmetry is staggering.
And to make matters worse for the U.S. in this scenario, Iran isn't just developing these asymmetric tactics in a vacuum. Krapivnik notes that the geopolitical landscape has shifted, and they have powerful backing.
He claims that Russia and China are already deeply involved in fortifying this asymmetry. He states they are providing Iran with advanced, real-time satellite targeting data.
Wow.
Furthermore, Russia is actively supplying Iran with modern electronic jamming systems to blind incoming U.S. missiles, advanced avionics, and specialized heat flares for Iranian ballistic missiles to help them evade those very Aegis defense systems we just discussed.
So if we synthesize Krapivnik's entire assessment, Iran possesses the impenetrable geographic fortress. They have mastered the cheap asymmetric swarm weapons that neutralize expensive naval assets, and they have the technological and intelligence backing of two global superpowers.
Yes.
Which brings us to the final and perhaps most alarming part of his analysis.
And the leadership disconnect.
Right. Because if you sit through this briefing, if you know that you cannot physically forge the steel to fix the refineries, you know that a strike will cause global agricultural starvation within months, and you know your military lacks the combat infantry for a ground war and cannot protect its ships from drone swarms. Why would any leadership structure willingly walk into that trap?
That's a great question.
Why does he believe U.S. leadership is seemingly still pushing for aggressive escalation?
Well, Krapivnik points to a massive systemic disconnect at the highest levels of Western leadership. He offers a very harsh assessment of these leaders, particularly focusing on Donald Trump, but extending the critique to the broader political class. He frames them not as grand historical strategists, but as marketing gurus.
He argues that the very structure of the modern democratic or Republican system, and he means the structure of the electoral government, not a specific political party, has devolved entirely into a popularity contest.
Exactly.
It systematically elevates individuals who are fantastic at branding, managing PR crises, campaigning, and selling a simplified message to the public, but who possess absolutely zero deep structural knowledge of military logistics or geopolitical strategy.
He essentially says that being a phenomenal marketer who can win an election does not mean you understand the physics of how to run an empire. And because these leaders lack that fundamental technical understanding of logistics and warfare, they are entirely blindly dependent on what their intelligence advisors choose to tell them.
Which leads to what he calls the information bubble.
Yes.
This part of the interview was wild, and it explains so much of the alleged overconfidence. He claims that insider sources revealed that during Trump's presidency, his daily intelligence briefings had to be radically altered to accommodate his specific attention span and preferences.
Right.
The standard presidential intelligence brief historically requires reading dense, highly complex, nuanced material about global risks. Krapivnik claims this was reduced to 3-minute video presentations.
Yeah, he explicitly references past public comments made by figures like Tulsi Gabbard regarding the push to reform the intelligence brief to keep the president engaged. Krapivnik claims these new briefings consisted almost entirely of highly sanitized cinematic highlight reels showing U.S. military strikes. Just high-definition video clips of American missiles perfectly blowing up targets.
It's like watching a Michael Bay movie trailer instead of receiving a sober geopolitical risk analysis. And the inherent danger there is obvious. These videos are entirely stripped of any negative reality or complex consequences.
Exactly.
They don't show the supply chain breaking down. They don't show the impossibility of hydro-testing a replacement vessel. They don't show the 100-drone swarm overwhelming the Aegis radar. They just show the explosion and the perceived victory.
Which naturally and inevitably breeds severe, unwarranted overconfidence. If the leadership only ever consumes sanitized, positive images of their own technological supremacy, they develop a profound delusion regarding their own escalation dominance.
They genuinely believe they can control the outcome of any conflict because every video they have ever been shown depicts them winning effortlessly.
It is exactly like a pilot believing the plane is flying perfectly smoothly because an engineer painted a beautiful fake horizon directly onto the cockpit window. They feel totally in control right up until the exact second they smash into the side of the mountain.
That is the ultimate danger of what Krapivnik terms the Kribuli concept.
Yes.
He claims that Western powers, operating inside this delusion of supremacy, act like bullies. They continuously push, sanction, and provoke smaller nations, assuming they will never face serious structural retaliation because they believe their own marketing.
But when the adversary finally hits back, when the spring unwinds, as he described with Russia, or when the asymmetric drone swarm is finally unleashed in the Strait of Hormuz, the West is genuinely shocked.
They cry victim.
Exactly. They cry victim, completely ignoring or failing to comprehend their own prior actions and escalations that led to that exact breaking point.
It is a systemic, institutional inability to anticipate physical consequences. They are treating a deeply complex, highly fragile physical world with the flippancy of a marketing campaign.
It is the terrifying prospect that the individuals making decisions capable of triggering the 3 waves of crisis, the sudden energy collapse, the global agricultural starvation, and the ensuing societal breakdown might be fundamentally, hopelessly insulated from the logistical realities of the decisions they are making.
Wow, we have covered a truly massive amount of ground today. We started by examining the snapping tripwires in the Baltic states, looking at how the informal rules of proxy wars and airspace boundaries are burning down.
We did.
We followed that erosion of restraint into the Middle East, detailing the brutal, agonizingly slow physics of hydro-testing and replacing 78-meter forged steel vessels. We explored the impending waves of global energy shortages and agricultural starvation caused by the fertilizer crisis if that infrastructure falls.
The 3 waves.
We analyzed the impenetrable mountain geography of Fortress Iran, the vulnerability of billion-dollar Aegis systems to cheap FPV drone swarms, and finally, the chilling prospect of global leadership operating entirely inside an echo chamber of their own marketing videos.
And as we conclude this deep dive, it is crucial to remind ourselves once again of our starting premise. These are the views, the logistical estimates, and the strategic models of Stanislav Krapivnik.
Right.
Whether you personally agree with his politics or absolutely loathe his historical framing, his logistical analysis offers a vital, unvarnished lens. It shows us exactly how adversaries and critics view the structural vulnerabilities of the West. When they look at the United States or Europe, they are not looking at our democratic ideals or our political rhetoric. They are coldly calculating our steel forging capacity, our diesel reserves, our Haber-Bosch chemical output, and the tooth-to-tail ratio of our infantry.
It strips away all the comforting narratives and leaves you with raw physical limitations. Which leaves me with a lingering, provocative question for you to think about as you go about the rest of your day.
Okay.
If the global supply chain is so intricately, hopelessly fragile that a handful of teenagers with cheap battery-powered drones in a 36-kilometer strait can potentially cause global starvation within 6 months? What does national security even mean in the 21st century?
That's the question.
Does it mean spending trillions of dollars building more aircraft carriers that can be swarmed by plastic? Or does it mean radically restructuring society to relearn how to forge your own steel, synthesize your own fertilizer, and grow your own food locally again? Because right now, the diagnosis of our global system isn't a clean, engineered X-ray. It is very, very murky. Thank you for joining us on this intense deep dive. Stay curious, stay informed, and we'll catch you next time.